Uh, my presentation is going to be different because it has no immediate asset pricing implications. So, but we think it has implications for investment decision making, particularly by households. And to give you a little bit of background about it, it's a project that has been ongoing with Bob Shiller since we first began to run monthly surveys of his famous investor confidence surveys. And now we have 25 years worth of survey data that Bob had envisioned and we've implemented at the Yale School of Management. It's also joint with Dasol Kim, who's at the OFR. And Dasol and I have embarked on a series of unusual research projects over the years. At least one of them had to do with the weather, which I won't go into. But the three of us share a real interest in testing some of the fundamental ideas that Bob Shiller's behavioral finance theories have proposed. And so you'll see as I describe what we're doing, how that develops. So we use the survey data. Now, when I say survey data, I'll tell you a little bit more about it. It began with Bob sending out paper surveys to people right after the crash of 1987, in fact. These were quite lengthy. He asked questions about what do people think the Dow Jones will be at 6 months from now, 1 year from now, then what's the probability of a market crash? What if the stock market went down by 3%? Do you think it will bounce back up? Is this a good time to be in the market? All of these really interesting questions. And the one thing that he did that's distinct from many other surveys that you're probably familiar with is he left a huge amount of space for free response. So, and this letter came from Bob's letterhead, basically. And so this was a chance for the survey participants to tell the Yale professor what they really thought. And so we got wonderful free response, some of it quite lengthy, but there's not much we could do with that for many, many years until along comes our ability with computer science to really analyze the text and to do things with it and to run topic models when we wanted to and so on. This is something that's very focused on emotions. And we're able, with Bob's survey, to test some theories about the relationship between emotions and probabilistic beliefs about things in a way that so far really has been accomplished only in laboratory settings. So that's what I'm going to talk to you about today. So that's pretty much what this slide says. The only thing I want to point out when I say laboratory settings is that there's a classic paper in the 1980s by Johnson and Tversky where I'll give you a little bit of preview about the tail end if I get to that part of the talk. They got college students in a laboratory, and then they gave them some paragraphs to read that were like newspaper articles. And so one set of articles would be about imagine a college student crossing the street, and then they get hit by a car. Something horrible, okay, that somebody could imagine happened to them. And another one might be, imagine a college student wins the lottery or something like that. So they prime them with really positive but unusual events. Both of those are very low probability events. And then, of course, they had controls of various sorts. Now, here's the interesting part. You won't be surprised that this awakening of some emotion might cause people to react and respond in heightened ways. But what they found out is that when they took the topic of what this event was, like if it was being hit by a car, they might have asked them about what's the probability of being involved in a plane crash, okay? Semantically similar things. Versus what's the probability of getting a rare form of leukemia. and so semantically different things. So you would have thought that if somebody's thinking about crashes of cars and airplanes and so forth, there might be some logical relationship between the two. In fact, they found none. So semantically dissimilar things, uh, 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 like leukemia and automobile crashes, that arouse the same kind of shift in their probabilistic assessment as something that was semantically similar. Then finally, they asked them about their emotional state when they were taking this test. And what they concluded was that the change in people's beliefs about a rare positive or negative event really was mediated by the emotional state and not by the semantic relationship. In other words, they're not basing their beliefs about an extreme event based upon based upon reason, but based upon an emotional arousal. How are we going to test that? Well, that's the kind of nice thing that emerges from Bob Shiller's data. Okay, so here's what we have. This is one question out of many questions. What do you think is the probability of a catastrophic stock market crash in the United States, like that of October 28th, 1929, or October 1987, in the next 6 months, including the case that the crash occurred in other countries and stretched to the US? Actually, Bob wrote this question at a time he didn't realize that the crash of 87 was not a catastrophe. It was just a bump on the road to a mediocre year in the stock market. But it's remained the same ever since. So that's the question. We've got a series of people answering these questions over years, mostly all by mail, although we do have one telephone survey. I'll let you look at this for a while, and probably it's the most important picture to look at. It isn't taken up to the present, but I like it because it's got the color-coded time series. Now, the survey crash probability is in the black, and if you look over on the y-axis, the crash probability and returns volatility measures are there. So you can see that people think that the probability of a crash like 1929 or 87 within the next 6 months is somewhere between 15 and 20%. That I call the Chicken Little effect. They think that something catastrophic is going to happen in the next 6 months. So they're just walking around. If this was a maintained belief, even when they weren't filling out the survey, they're walking around with this notion that that the market could drop precipitously. Now let's see, okay, that sounds irrational. But now look at this green line called the option implied crash probability. When we look at the prices of options for far out of the money insurance against the stock market crash, you can derive from that some sense, and there's some technicalities about how much it's accurate, how accurate it is, but you can derive from that some sense of what the market itself believes about the probability of a stock market crash, because people are trading options. And so when the probability of an extreme event goes up, then we're going to see the VIX, that's the volatility indicator, also go up. So this option implied crash probability, the volatility of the S&P 500, which is also being set by market participants, those things are going up. And typically that's also at a time when the respondent's belief is going up and down. The problem here is not that the time series is that off. It is a deviation a little bit, but the issue is how great is the distance between the market assessment of risk and the respondent's assessment. So what do we do? Well, we say we're going to study that split between the two, the spread between what the responders are telling us and what the market is telling us. And we're going to look at the free response that we get by using a large language model that we trained to detect emotions of various sorts. And so here, we term this open emotion, and we worked very closely with a young scholar named Francesco Fabozzi, who trained this model for us. And the way that we trained this model actually is kind of interesting. I know some of you in the room are really interested in the technology of it, but what we needed to detect the probability or assess the likelihood that a certain kind of that 6 or 8 different emotions are present in the language that is being used. Okay, so that's not a 0-1 thing. There are lots of different emotions. So what we had to do is generate a fairly substantial training set that we then had, that means 1,000 different questions, which represented the range of different kind of emotions that we're interested in. And then we had 2 human scorers go through and assess those probabilities. So that's a fairly substantial amount of training. We generated the questions with AI so that we could make sure we got a good range. We used an open source mistral model to do the training. There's some interesting issues about LLM training, and which are certainly something that we could talk about later. And here's the description, like I said, of what we did. I'm going to show you a little bit about how it, depending on time, I want to make sure.
7 minutes.
Okay. This is just about the concordance between the way that the AI is scoring, and it kind of, you can look at how you would assess this with a few representative questions. You got to say the AI is pretty clever about thinking about things that would generate these kinds of emotions. There's a little bit of benefit to using larger models, but even the small model, the $7 billion, $7 billion, $7 billion, you know what I mean. One shot and untrained versus trained, there's quite a bit of benefit. So the training is working pretty well. And we did this a little while back, so we're using some of the older technologies, but we train on this set of emotions, and then we ask it for 2 different dimensions, which are sentiment and arousal. So you might think about it as the sign of the emotion, negative or positive, versus the intensity of the emotion. There's a part of the paper that's all about testing something called a circumplex model in psychology. And for those of you that are interested in emotion scoring, we got some kind of cool results that indicate that you can't just use sentiment when you're trying to assess its effect on people's beliefs or their actions. And in finance, we often have just a standard sentiment score. So that's another topic that's in the paper. Now, we also know the day that they filled out the form. So we can go to the news and see what the sentiment in the news and the emotional content in the news is. And this is just a slide to show you that investor sentiment in terms of predicting the probability of stock market, high probability of a stock market crash, is much stronger than if we use the sentiment derived from the news articles on the day of that that the respondent filled out the form. So in some sense, we're good. We're able to control for the sentiment of the news, as well as assessing. Again, it's a collider problem. What happens when they pick up the newspaper, they read, and they get excited because the news tells them to get excited? What are they going to do? Well, we try to control for that. Okay, now, what are the emotions that make a big difference in terms of predicting a stock market crash? We've got anxiety, fear, and sadness. That's not a big surprise. Disgust is a little bit less, but disgust is a kind of an orphan emotion that comes out when people do research in affect. And then, so the signs are kind of nice. The principal component obviously is going to be a pretty powerful predictor here, because we got some nice longs and shorts here for the first principal component. So, so bottom line is, when we look at the spread between what the market predicts for us, the probability of a stock market crash, and what our respondents predict is the probability of a stock market crash. When we look at that spread alone, we say, how much is that? How much can emotional content explain? Let's call it don't quote me, but how much can the emotional content explain the irrational belief in a crash? That's what we're finding. And first of all, we find that the emotions are quite significant in predicting that spread. What I didn't show you is what people that work with these options would naturally ask is, well, how much does the emotion predict the price of an out of the money put fluctuation? Because after all, there are people buying the puts as insurance against some big event. Not as much as we had hoped, relatively little, which is somewhat of a disappointment, but it makes this a bit cleaner here. We believe these are not the marginal investors who are competing with more rational people about setting market prices, but maybe these are just, they say they're investors, but maybe they're not really involved in the price setting of these things. Okay, in just a few minutes left, I thought I would show you how we circle back around to test this Johnson and Tversky theory, laboratory findings. So here's what we did. There have been papers about earthquakes in financial markets, believe it or not. We're not the first to say, let's use earthquake as an indicator of a surprise negative event. But what we did is we located, for our survey participants, we know when and where they answered. And so we found moderate, well, we had extreme earthquakes as well, but we focused on moderate earthquakes that happened with a fairly recently and close by them. And our prediction was that these are so semantically separated that it's a kind of a clean test. And so we found a positive association for individual investors, but not so much for institutional investors, which is a nice distinction, between a recent earthquake and their prediction of their belief in a high probability of a stock market crash. So there's some. So there you have the when we aggregate it, pooled, it's significant. When we look at the individual investors, it's significant, but not for the institutional investors. So for those of you that use stock market brokers, you think, can I trust my advice from my professional? At least be assured that our evidence suggests they don't panic when something crazy happens. So anyway, thank you very much for your attention.